Welcome everybody to the final day of the Tableau conference here in New Orleans. Glad the rain held off till this morning. It didn't bother us all last night. My name is Ross Bunker. I'm a principal engineer at Tableau. I've worked on a lot of different areas of the product over my 13 years there. Table calculations, connections, web client, data blending, LOD Expressions most recently. And I do want to clarify, I'm going to talk about LOD Expressions a little bit today, but that's not the focus of this talk. So if you really want to learn more about LOD Expressions, this isn't quite the right place. It is in the title, so I do want to just let people know that. And I'll close my eyes for a couple of seconds. If you want to run out, go with something else. But what I want to talk to you today about is just sort of the general concept of level of detail in Tableau. Because although level of detail expressions is kind of this very front and center piece where we use the term level of detail is not otherwise used a lot in Tableau when we talk about it. But it's very central to a lot of what Tableau does. And so what we'll do today is talk through why LOD matters. And then we'll talk a little bit about what LOD, level of detail, really is. And I want to talk about it sort of less at a sort of abstract technical way and much more concrete. And then in the second half, what we're going to focus on is walking through sort of the history of Tableau and how level of detail manifests in a number of different features that we have in Tableau and how that affects the questions that you can ask. And then finally, I'll talk a little bit about kind of the future and how some of the future features that we're working on will let you access other types of level of detail and help you ask different questions. So just to start off, why does level of detail matter? Well, when we talk about level of detail, what I'm going to talk about it is in reference to the questions you can ask. And questions are central to how Tableau produces value. Right? We talk about our mission of helping people see and understand data. And a key there is really the understanding. And how do we arrive at understanding? We arrive at understanding by asking questions and seeing the answers in our data in Tableau. But asking the right question is really important. So W. Edwards Deming is a famous electrical engineer by training, but he's best known probably for the work he did in bringing rigorous statistical analysis to product quality. In particular, he was largely responsible for a lot of the rise of Japanese industry and their ability to produce high-quality automobiles and other electronics. And he had this great insight that if you don't ask the right question, you don't discover anything. And I sort of took that idea and I reworded it for Tableau. So if Tableau doesn't let you ask the right question, you can't find the answers that you need. So using Tableau is all about how do I use the features of Tableau to help me answer the question that I have. So what is the question that we're asking when we have a visualization in Tableau? So this is the answer to some question, but let's tease out what that question is. So clearly we've got products and product types, and we've got our sales totals. So this is one way of thinking of what the question is here. What are the total sales of each product? And help me see by product type too. Now, here's another visualization, also answering some question. And if we look at this, we see a couple of different measures here: count of employees, employee salary, and regions. And so we might think, well, this is answering the question, what is the salary of employees in each call center region? But if we look at this closely, we might be a little suspicious of this question and answer, because the answer here is telling us we're paying our employees $3.5 million apiece, which seems a bit excessive. Although if I was one of those employees, I would not necessarily complain. So what's going on here is something we call the replication problem. And it lies in understanding the level of detail that our question is at, which is at employees, and the level of detail of our data. So let's dig into the data a little bit. So if we look at one employee, we can see that, yeah, okay, so there's one employee name there, and their salary is apparently $1.7 million according to this visualization. But let's dig in to the underlying data. So we view underlying data, we see all of these records, and if we zoom in, you can see that this employee, Chris Abe, has a salary of $77,000. But the problem is that it's being replicated once for every single product, right? And so this is what's happening is we have data which is at the product name, the product sales level, and we're trying to use it to answer a question about employees. And so we've taken and we've summed that salary, and it's been replicated for every product name. So it's not answering the question that we thought it was. So what is level of detail? So this is a visualization that our esteemed sales consultant, Alan Eldridge, built to help explain some features in Tableau. And I've appropriated it with full attribution, as you'll see, to use in this talk as we go through talking about level of detail. So just to go over it, right, what we've got here is, two different ways of looking at level of detail. We have aggregation, which goes less aggregation to more, and granularity, which is sort of the complement. So we have less granularity up here and more granularity down here. And so down here, we have our original data. It's totally disaggregated. Every row of our data is present. And up here, we have one number. And so it's drawn this way because this is sort of how Tableau works when you use the user interface, right? If you drag out a measure in Tableau, you get one number. And as you drag out more dimensions, these arrows, you get more and more detail. You get less aggregation and more granularity. Now, you could draw this the other way, and we could talk about how you roll things up. But because the Tableau UI works this way, I've chosen to just choose this pattern to follow. So we're going to use this to talk about level of detail in the product. But it's not necessarily the best way to think about level of detail. It's a very technical way. You could also think about it in terms of SQL if you're a database person, and it's the level of detail is the group by columns that you have in your query, or if you're purely a Tableau person, you want to think about it in terms of, it's the dimensions you have in your visualization. But I kind of want to step back from those sort of technical definitions and think about it in terms of the real world things that it means. So let's take this example. What we have here is a purchase order, and it's a very concrete real world thing, right? This is a piece of paper that exists, well, perhaps not real anymore these days, but it's at least virtually a real thing, if that's such a thing. And there are many things, and I use that term very deliberately, in this purchase order. So we've got a salesperson at the top. In this section, we'll list the producer who's producing this particular product or the set of products that we're selling. We got the purchaser to whom we're going to deliver these products. We've got the products themselves listed in this area. We've got the company of the salesperson who's selling the product. But there's actually multiple companies here, right? We've got also the company of the producer, and we've got the company of the purchaser. There's also multiple states. We have the salesperson state, the purchaser state, the producer state. There's multiple times, too. We have the order date that the order was made, but we've also got the ship date, although it's not pictured on this particular thing, but you can imagine in my data set I would have that information. So these are all the different things that are in this purchase order and in data that I would have about these purchases. So what types of questions does this enable? So some examples of questions that I could ask using data from this purchase order. What are my total sales by date? I'd be pulling out the date from here and the sales from there. How many units of each product did I sell? I'd be pulling out quantities and product names. What is the highest volume producer in each state? So I'd be looking at how much they produced and the state for that producer. Now notice here, I'm not looking at the producer name, right? I'm looking at the producer state. And so there may be many producers in a single state. So even though my information is about producers, it's not at the producer level, it's at the producer state level. So it's a slightly different level of detail than the producers themselves. Similarly, zip codes with the most purchases, so I can see what areas my purchases are coming from. So the common pattern here to all of these questions is, for some given set of characteristics, what is my measurement, right? For my zip codes, how many purchases did I have? For each state that a producer is in, how much volume did I produce, right? And so the common pattern here is like, for this given set of characteristics of these things, right? These are real things. There's a salesperson, there's a producer, there's a purchaser. These are real things in the real world, and they have these characteristics, states, zip codes, et cetera. I want to know what my measurement is. And so that's what really LOD is, right? LOD is this set of characteristics that are associated with the measurement I want to make. And, I couldn't find any more generic words to put into this sentence. I looked for a while, but I think I got them all. So it's a very generic sentence, but that's because it's trying to cover this large ground, right? So the reason this is important is because when we talk about answers, it's important to remember that it's really the question that is driving your thinking, right? The question is the thing you're asking. The answer is what you're getting. So getting back to what W. Edwards Deming said, asking the right question is the important thing. And so the question is, how does Tableau help you ask the right questions? And how do the features of Tableau enable you to ask the questions that you have? So now let's go ahead and look through Tableau and look at how LOD appears in the different features of Tableau. And I'm going to kind of go in chronological order here. So the very first thing that Tableau does is connect to your data source. And when it connects to your data source, the level of detail that you have is your data, right? Your data model exposes a single flat table as what we call the row level of detail, the row LOD. And that's down at the bottom right here, right? It's all of the rows in my data. And as we saw in that first example with the employee salaries, that's a really important level of detail because there are questions that I can ask only if I have the right data, only if I have the right row LOD. Now, so we saw the perils of asking questions of data where the LOD was not well matched, right? We had purchase data and we were asking employee questions. On the flip side of that, what if I have questions about daily stock trades, but my data is at the monthly stock value level, right? I can't ask those questions. So you have to align those two things. And if you saw the keynote on Tuesday, you got to see a demo of some of our upcoming data modeling capabilities, which are going to unlock some additional ability for us to answer more questions with a data source. And I'll talk a little bit about those at the end. But for right now, here we are, row LOD. Very first thing, when you connect to data in Tableau, this is what you get. So the next level of detail that's really important is the Vis LOD. And this is central to everything Tableau does. This is really the central concept behind Tableau. What we have when we take our measurements and put them on a visualization, put them on the shelves, and we take dimensions and we put those on the shelves, what we're generating is exactly this Vis LOD. And what Tableau does is generate queries that roll the data up to the Vis LOD. So this is really the fundamental level of detail that your questions are being answered at. So we come back to our original example here. What are the total sales of each product? Help me see by product type 2. And it's pretty obvious, right? Product type, product, that's our LOD. And that's where our sum of sales is measured to. Perfect. But there are lots of other LODs in Tableau. And so what I want to do now is kind of walk you through different features of Tableau and how they access different levels of detail. And the key takeaway here is that answering a question can often imply multiple levels of detail that are involved. And by understanding how these different features of Tableau let you access those, you can incorporate them into the visualizations that you build. So the first one we'll look at is the summary LOD. So you have a question, and you get your answer at the Vis LOD, but you also have some part of the question which wants a summary of that, right? And so the summary LOD actually takes data that's at the Vis LOD or below and puts it in your visualization, which is at Vis LOD, but includes this information at a higher LOD. So what does that look like? So how do my individual product sales compare to the average sales for all products? So this is really the same visualization as we had before with our Vis LOD, but I've got something new on there, right? I've got this reference line. And this reference line is averaging each of these bars and creating a single line that represents that average. Now, what I think is really interesting and important to note here is that I have sum of sales, which is rolling everything up to product type and product, and I have this average. Now this average isn't against my original data, right? If I was to average my original data, and I changed my aggregation to average up there instead of sum, now my average sale is in this sort of 100 to 300 range, except for regular espresso. And my average reference line is now right there around 200. So that's very different. It's a different question, right? And so you can see here that this average reference line is not about the average sale. It's about the average total sale for each product. So it's taking the numbers that I generated at that Vis LOD, and it's averaging all of them. And that's a fundamentally important thing. Now, other features that let you access summary LOD are things like totals and table calculations that do window averages and those sorts of things. And so those features can all let you include that level of detail, those types of measurements and information in your answers. So the next level of detail I want to talk about is filtering. So filtering is interesting because you can use it without really thinking about LOD, right? I can filter out particular products or particular product types or whatever dimensions I want. I can even filter at Vis LOD. So if I filter out things, and say sum of sales greater than 1,000 or sum of sales less than 1,000, then as my visualization changes, those filters are going to change because they're filtering fundamentally at Vis LOD. But you can also create filters that filter at a different level of detail. So what this picture shows is this idea that I have this filter on customers where the sum of sales for that customer is greater than 1,000. Now that filter is done completely independent of whatever my visualization's level of detail it is. Whatever dimensions I have in my visualization aren't relevant. And this is a conditional filter in Tableau. So when you click on the condition tab and you say, I want customers who have sales more than 1,000, that's only looking at customers, aggregating, computing the sum of sales for each customer over all the rest of my data, and then computing that number and seeing if it passes the filter or not. Now, what kind of questions can you ask with that? So here, I have the question, how do sales of products fluctuate over time for products with lifetime sales greater than 40,000, right? So if we look at this, it's pretty clear that none of the marks here, none of the points on the lines are higher than 40,000. So what the filter is doing, and the filter's on product, you'll notice, it's not on sum of sales. So that filter has a condition on it that says sum of sales greater than 40,000. So what we've done is we've basically taken and computed for each product its total sum of sales over all time and everything else, seeing if it's more than 40,000, and then getting that list of products. And given that list of products, showing those products on this visualization. So it's completely independent of what I do in this visualization. If I drag out more measures, that list of products is not going to change. And so these are the types of things you can do with those filter LODs. You can restrict your products to a given set. And in fact, that's also what sets are, in a sense, is they're these saved filters. So again, using filter level of detail, you can ask different questions than you can ask of your Vis LOD. So the next level of detail I want to talk about is the extract. Now, usually when we use extracts, we probably just extract all the data, and that's a perfectly great use of extracts. But there's a little known feature in extracts that lets you actually change the level of detail of your data. And this can be very useful if you have questions that are at a slightly different LOD. So what the extract LOD does is when you create the extract, you actually specify, and it's restricted to date information, a particular level of detail that you want to create the extract at. And when it does the extract, what it does is it actually, instead of bringing all the data in, it actually runs a query that does a group by and aggregates your data up one or more of these levels and creates your extract using that data. Then you can use it to answer slightly different questions. So what does this look like? So let's say I have a question like, what are my average monthly sales for each year and quarter? So if I was to simply take the quarter and put it out on the Viz, which is giving my years and quarters, and ask for average sales, you can see the numbers here are between 1,500 and 2,000. But if I drill down to the day level, you can see that, well, my numbers are still in that sort of range, right? 1,500 to 2,000. So when I have this average, I'm not actually, because my data is at the day level, remember a row LOD is really important. Because my data is at the day level, the average is going to be average daily sales, not average monthly sales. So what I want to do, right, is I want to take my daily information, I want to aggregate it to the month level, I want to sum everything to the month level to give me my monthly sales totals. And then I want to average it for the quarter. Well, you can do that with LOD calculations today. Back when we did this feature, you couldn't. We didn't have LOD calculations. And there could be performance benefits if you have a lot of questions about monthly sales to using an extract instead. So how does that work? So what we really want is this, right? We want our month sum of sales to give our monthly sales totals. And so when I create my extract, I can check this box, aggregate data for visible dimensions, and roll up data to the month level. And so what I'm doing then is every measure has a default aggregation, and we'll apply that aggregation, compute the roll up to the month level for all the data, and store that in the extract. So then when I'm querying for my sales, instead of querying my daily sales, I'm now querying monthly sales. And now you can see that my numbers here are not in the 1,500 to 2,000 range, but rather the 1.5 to 2 million range. So I'm now averaging my monthly sales and no longer my daily sales. So again, here we have a way of actually changing our row LOD to better answer the questions that we have. So another level of detail that's important, although in a different way, is how our geocoding works. So geocoding lets you combine data that's based on these geographic fields, like state, city, et cetera, when those fields are in your level of detail. So what's interesting, though, is that the way this works is it's not that every row has to be assigned a unique latitude and longitude, right? I can have a bunch of marks that have the same state. And what geocoding does is it latches on to the parts of the level of detail that are geographic in nature and just uses those pieces to figure out what your latitude and longitude are. So here's an example of that. What's the sum of sales in each state, and how does it vary by product type? So more or less the same data I had before, product and product type, but now broken down by state. And what you see here is we have little pies on every state. And you know, this is known to be the one and only place where you ever use pie charts in the world, apparently. But the key here is that each of these marks, each of these pie slices, has the same latitude and longitude. And so geocoding is smart. It looks at your level of detail, pulls out the things that it cares about, namely state, and it simply matches up the latitude and longitude with each of those. So each of these 4 pie marks on every state, except I think there's one that only has 3, maybe a couple. Each of these pie marks gets the same latitude and longitude because that piece of the level of detail, that state, is the same for all of those marks. Now, in and of itself, this isn't necessarily groundbreaking level of detail or even that important because it just works. But we took that same concept and we used it in a new feature called data blending that came after geocoding. Now, in data blending, we enable you to, instead of just joining with some geocoded data, we let you take any other data source and we figure out how to bring that data into the visualization. And what matters is the level of detail of your visualization. So we have our normal, visualization pipeline here where we're aggregating the data so that we can visualize it. But in addition, we have this other thing going on where we can take data from another data source and bring it in to the visualization. And that data might have a different row LOD than our other data. And we actually aggregate it to align it with the level of detail of the visualization, or a subset of it. So let's take a look at what kind of questions we can answer with that. So here we have, how are my regional sales doing versus quota? Right? So I have my regional sales for every year and market, and I've got this other piece of data that is my quota. So that comes from a data source that looks like this, right? My row LOD here is year, quarter, market, and I have my sales quotas. But you'll notice that quarter is in this visualization, and it's not in my, quarter is in the row LOD here, but it's not in my visualization. So what happens is, we go to that data, we aggregate it to the year and market, rolling up the quarter, aligning it with your visualization's LOD, and then we can bring that data together. So in the same way that data blending lets you bring in that latitude and longitude, you can bring in any other data as long as you can align their fields with the level of detail of your visualization, or a subset of it. So that's great, and that lets you answer a lot more questions where you have 2 pieces of information, 2 sets of data that have different underlying row LODs, but have some common level of detail that you can bring them to. But what if the common level of detail you want to bring them to is not in the level of detail of your visualization? So we extended data blending then to support the ability to have a join level of detail where you're bringing the data together that was below the Viz LOD. So we do the same basic process of aggregating the data from both data sources up to a common place and joining them, but then we let you aggregate that up to the Viz LOD. And so sort of throwing away some of the dimensions that you used to bring that data together. So what kind of questions does that let you answer? So in this case, I have the question, what is my profitability in each sales territory? Well, it turns out my underlying row LOD for my sales data doesn't include sales territories because we keep that in a separate place. If I have the customer state being the common thing in both of them, I then have this territory which is only in this particular piece of information, only in this data source. So what we do is we take our underlying data, we aggregate it to the state level. We do the same in the second data source, which is trivial since it's pretty much already at the state level. We bring them together, and then we throw the state away and we aggregate to those territories. And we get the right answer, which is always good. So we can answer new questions because we can bring data together that is at a level of detail which is not the same as my Vis LOD. So the final thing I'll talk about is LOD expressions. So LOD expressions are the first place where we really introduced a formal definition and sort of a very explicit level of detail into the product. Up to now, level of detail is very implicit, right? There's Vis LOD, there's filter LOD. I'm not actually declaring it anywhere. I'm just sort of using it in my calculations implicitly. LOD expressions, though, are the first place in Tableau where you actually, in a calculation, specify the level of detail you want a computation to occur at. You give us the dimensions, and then you give us the computation, the measure that you want. And of course, we have a couple of different kinds. We have fixed LOD expressions, which declare the full dimensionality, the full set of dimensions that you want in your LOD, and we compute to that. We also have the include and exclude versions where you can make it relative to the Vis LOD. So include this dimension, compute this value, or exclude this dimension and compute this value. And again, I'm not going to go into a lot of detail about all the different use cases for that. There's some great talks on that. But the key here is that it really lets you access some other levels of detail and bring that information into your visualizations. And you can use it in two ways. One way is to use a fixed LOD calculation and build a new dimension value that you can use as an LOD itself. Other ways you can use for example, I mentioned when we talked about the extract LOD, if I had daily data, right, I could say exclude, or I could say include month, sum sales, and then I could compute the average of that result. And what that would do is it would take my Vis LOD, add month to it, compute the sum of sales to give me my monthly sales values, and then I could average that or do whatever I want with it, right? So that would be a way to use LOD expressions to do those those monthly sales numbers when my row LOD is not actually the right LOD. So let's take an example of a question we can ask with LOD calculations. So does the month in which a customer makes an initial purchase affect the long-term spend? So this is one of my favorite use cases for this. So the idea here is that I have my purchase data, and I have all these customers and all their purchases. But what I want to know is, when did a customer make their first purchase, right? Well, I can compute that number. I can use an LOD calculation that says fixed customer, min date. And that's going to, for every customer, compute the earliest date that I saw a record from that customer. So now I have that value, right? For every customer, I know that min date. Well, now I can use that as a dimension and say all the customers who had a min date in January, what are their total sales? All the customers whose min date was in February, what are their total sales, right? And so I can answer this question now because I computed that value at a different LOD, at a different LOD than my row LOD and at a different LOD than my Vis LOD. So the key thing I want to get here is each of these questions after the first one access multiple levels of detail to answer a question. And you can actually combine these in many ways, right? Most of those only had 2 LODs involved, but you could imagine ones that use 3, 4, 5, many more complex levels of detail. And so there is this white paper written by Jock McKinley and Chris Stolte. Chris is one of our founders. And they wrote a paper early in Tableau's history called There Is No Single View. And the key idea behind it was that one of the powerful things that Tableau did was it enabled people to create many different types of visualizations. And that's important because for a given answer to a question or a given analysis, there's no single visualization that is going to give you the right answer. You sometimes need to compose different visualizations or move through different visualizations to arrive at answers that are important to your questions. So I took that idea again and appropriated it, because apparently that's what I do. And there is no single LOD. There's no single level of detail that will always be the one. Questions require different levels of detail, and the way you access those different levels of detail in Tableau can help you answer more questions and richer questions using Tableau. So I've given a bunch of examples of questions that you can answer with Tableau that use different levels of detail, but there's still some questions that are somewhat challenging in Tableau. So what is the ratio of my employee sales to their salaries, right? So we saw earlier how this replication problem can make this tricky. Now, again, you could do this with an LOD calculation today, but you really have to think about it, and you have to write that LOD calculation and make sure people use it and don't accidentally use the wrong one. But one of the things that our data model does too is it throws away data. If my data source is this purchase order information and I'm asking employee questions about it, employees that don't have purchases or that aren't salespeople aren't going to show up in it. Or a new employee who hasn't yet had a sale isn't going to show up in it. Or if I have questions about states that aren't in my results aren't going to show up. And so your level of detail then can also affect what data shows up in your answers and give you misleading results. And I can't answer questions about states that I'm not selling in. Another question that comes up is plotting two different types of data together. So where are my customers relative to my stores? Well, I could join my customers with my store data, but I'd have to sort of associate every customer with a single store, right? Or maybe multiple, but then my customers would be replicated and I'd get sort of two plots. What I'd really like to be able to do is to put customers on a map, and then on that same map, put another set of data from stores, and those two things are totally not related, right? They're only related by the fact that I'm putting them on the same map. They have different levels of detail, they're different pieces of information. Can't do that today very easily in Tableau. And then finally, I might ask questions like the last one about average sales for the top customers in each state compared to the rest of the customers in the state. So if I would just want to know about my top 10 customers, you can do that in Tableau. It's a little complex. You have to do some context filters to get your states and that sort of thing, but it's totally possible. But if I want to aggregate the rest of the customers together, well, as soon as I'm doing aggregation, that sort of needs to happen in the database. And so I need to do the ranking and do the aggregation. And we can't really do that today because we don't support ranking in the databases. Now, some databases support it using some sophisticated syntax and that sort of thing, but obviously we want to make Tableau, make these questions easy in Tableau. So let's talk a little bit about the future and what we can do in Tableau to make some of these things easier. So regarding that last one, right, we want to be able to do richer computations even when things aren't supported in the database. So if the questions you can ask are restricted to the database, the capabilities of the database you're using, that's hard, right? You guys shouldn't have to know about that. And one of the great things is we have in Hyper a data engine that Tableau can use that has all of these rich computations available. So one of the things we're working on is ways for us to be very smart about moving data into Hyper behind the scenes without you even knowing, doing computations, and then reusing those computations in ways that are transparent. So the second thing is about combining data sources with different LODs in the same visualization without requiring blending. And so this is a really powerful feature. And a great example is that idea of being able to plot data that is on maps together. And you know, this is one of the things we're looking at really hard. There's some very interesting challenges in it around how to make it easy and how to make it understandable what's happening. In addition to that, while the initial request is, well, really, I just want to see them together, the next thing we know you guys are going to want to do is write calculations that do that. Like, okay, show me which customers are closest to each store, right? Oh, well, now it gets complicated. So we're really looking at trying to figure out the best way of exposing those features, enabling those types of questions without creating a huge amount of complexity. So the final thing here is supporting richer data modeling, in particular where we have different levels of detail. And this is what we demoed, this is what we demoed on Tuesday. So these richer data modeling capabilities where you can take data at different levels of detail, join it together, but instead of Tableau's data model saying, oh, those are now all at the same level of detail, we'll remember where each measure comes from and be able to identify that level of detail and use it intelligently, essentially generating behind the scenes the right LOD calcs to prevent problems like that employee salary. And so one of the outcomes of this will really be the fact that you can answer more questions with a single data source. Because today, if I have questions about purchases and sales, I use the sales data source. If I have questions about employees, I need to use the employee data source because that's got the right LOD for those questions. If I've got questions about my customers, I use another data source that has the right LOD for those questions. But in this new world with richer data modeling, I can create a single data source that has access to all of my data, employees, customers, sales, and use it to answer those questions. And depending on the question, it will give you the right answer because it understands the LOD of the question and how the measures in the question relate to one another. So that's all I had. I'm happy to talk more, answer questions and that sort of thing. Thank you very much for coming. Thanks for coming to Tableau Conference, and I hope you have a great rest of the day.